Hello my friends, alright, let's start the implementation of the upper confidence bound algorithm. So we're gonna make it step by step, and you're gonna implement each of the steps first before we do it together. And that first step, I've prepared the slide here, we're gonna have a look at it many times. The first step is that at each round, for each user, because a round corresponds to a user, we consider two numbers for each add I, from 1 to 10. This first number, NIN, which is the number of times the add I was selected up to round n, so make sure to understand the indexes here and the variables, and then RIN, which is the sum of rewards of the add number I up to round n. Okay, so the first step that I would like you to do, and I'm going to ask you to press pause on this video, the first step I'm going to ask you to do is to make these two variables, create two variables for these numbers. The number of times the add I was selected up to round n, and the sum of rewards of the add I up to round n. So create these two variables, and then also, in the same step one, I would like you to create other variables. The first one is the total number of users to whom we will show one of the ads, and that's 10,000. So I would like you to put this 10,000 value in a variable that you can call capital N. Then I would like you to create another variable for the number of ads we have, meaning 10, and you can call this variable lowercase d. After this, please create a variable that will contain the list of the selected ads over the round. So, it will start as an empty list and will become at the end a list of 10,000 elements corresponding to the 10,000 ads that were selected to the 10,000 users successively. Then please create these two variables. So this first one, NIN, you can call it numbers of selections, and you have to, of course, initialize it as a list of 10 elements only containing zeros, and I will show you a trick to do that easily. And for this second variable, RIN, you can call it sums of rewards, and same, you have to initialize it as a list of 10 elements, but initialized with 10 zeros, and we will populate these two lists over the rounds, okay? And finally, I'd like you to create one last variable, which is the total reward, and which will simply be the sum of all the rewards received at each round. Because it's important to remember that the zeros and ones in the dataset are in fact the rewards, the single rewards received at each round. If the user clicks the ad, then we get a reward of 1 at a particular round, and if the user doesn't click the ad, we get a reward of 0. We get no reward, basically. Okay, and the total reward here that I would like you to create as a final variable will be the accumulated reward, meaning the sum of all the rewards collected over the round. All right, so let's do this. Please press pause on the video, and in a second, we will implement the solution together. All right, welcome back. Let's do this. So first, let's create a new code cell, and let's create each of these variables one by one. So at first we said that we wanted to have a variable for the total number of users, or the total number of rounds over which we're going to show ads to the users. So there we go, we want to call it n, capital N equals, and that's 10,000. All right, 10,000, yes. Then we said we wanted to have a variable for the number of ads, meaning 10, and we want to call this variable lowercase d equals 10. Perfect. Then, as we said, we want to have the full list of the ads that are selected over the round. So, at first this will be an empty list, and over the rounds it will get bigger and bigger up to, at the end, it will be a list of 10,000 elements. And the nth element will be the ad selected at round n. All right? So we're going to call this variable add underscore selected, and this will be initialized as an empty list, just like that. Add selected, all right. Then next one, well, the next two ones are these two, NIN, the number of times the add I was selected up to round n, and RIN, the sum of rewards of the add I up to round n. So for the first one, we will call it numbers of selections. And since we want to have these numbers of selections, these numbers of times each ad was selected for all the ads, well, this will be initialized as a list, but not an empty list, but a list of 10 zeros. And the trick to initialize this list of 10 zeros efficiently is to just add here times d. All right, just like that. This will initialize this list as a list of 10 zeros. And then each time we select an add, for example, add number 3, well, the third element of this list will be incremented by 1. All right, so at first it will be 0, then let's say add number 3 is selected, it will become 1, then let's say add number 5 is selected, we will replace 0 by 1, and then each round it is incremented each time a new add is selected, okay? And at the end we hopefully want to see one add that is selected way more than the others, and UCB will figure it out. Okay, then next variable, this one, the sum of rewards of the add I up to round n. Well, same, here we want to have these sums of rewards for each of the adds up to round n, and therefore we're going to create another list which we're going to call sums of rewards, right? And same, this will be initialized as a list of 10 zeros. So I'm just copying and pasting this, right? That's the same. And of course, at first round, well, each add has a sum of rewards equal to 0, because at the beginning no add is selected and therefore no reward is collected. Then, as we said, we want to have a final variable, which is the total reward accumulated over the rounds, with the different adds we select at each round. And let's call this variable total underscore reward. And of course, we have to initialize it as 0, because in the first round, well, no add is selected yet, and therefore no reward is collected. Okay, good. So we have all the parameters all initialized correctly. And now, what do you think will be the next step? Well, of course, the next step will be to start a for loop, which will iterate through all the different rounds, starting from round 0, because, in Python, indexes start from 0 up to round 10,000. And at each round, well, we will follow these two steps. We will compute the average reward of add I up to round n. Then we will get the confidence interval. And in step 3, we'll select the add that has the maximum upper confidence bound, the higher upper confidence bound. All right, so you will see this will be very easy. We will just follow these steps and I will ask you to implement them first, but no worries, I will guide you. And so now let's take a little break, because this for loop will, actually take a few lines of code. So make sure to have good energy for this, and then let's smash this together. Until then, enjoy machine learning.